start. We always ask questions, right? It's important. We have studied the single phase transformers, ideal transformers. We have studied the RLC circuits response in AC circuits. But let's begin with the first question. The first question is why three-phase system is advantageous over single-phase system. But before we answer that question, the first thing first, we do know what single-phase system is, right? The single-phase system is the supply voltage that we receive from the mains power socket. And when an electrical conductor or load is connected to the supply voltage, then there will be an alternative current flow through it. And we have already studied the concepts, fundamentals about single-phase systems, and it is very important and relevant to repeat at this learning outcome. A single-phase supply voltage, as we know, that is 230 volts minus 6% plus 10% tolerance at the supply frequency of 50 hertz, and we consider it as a reference angle or reference point, that is 0 degree. That means 230 angle of 0 degree volts, and it resembles the mathematical sinusoidal behavior, and that's why we call it sinusoidal. And of course, when the current flow through the conductor, we will be able to see that it has a sinusoidal response. We are already aware about the RMS, average, peak to peak, peak voltages, instantaneous voltages. I'm not going to repeat those concepts, but it's important to know what these concepts are before we understand or try to understand what the three-phase system is. So I will have to come back to this sinusoidal AC waveform because we need to know where this three-phase systems comes from, why we need a three-phase systems at the first place. Of course, we want to know why it is advantageous compared to the single-phase systems. And of course, like I said, that it is important to know where this three-phase system or three-phase supply comes from. So let's begin with the first question, that why three-phase system is advantageous over single-phase system. Well, let me put in this way. You need to generate a voltage. You need to transmit that voltage over the longer distances. In order to transmit the voltages over longer distances, we need a transmission line. But we also need a set of mechanisms that how we are going to supply that voltages. So these are not 230 voltages. These are voltages in thousands of volts or maybe megavolts. So in order to transmit the large amount of power from one place to another place over the long distance, then we need a particular system, and the most commonly used system is a three-phase system to transmit or to transform the power over the long distance with the minimum possible losses. Three-phase system is also advantageous in the machines like motors, because if you do remember, I've been talking about the MMF. There are three types of MMF. One is static MMF, second is alternative or pulsative MMF, third is the rotating MMF. Now, rotating MMF is relevant to the machines, to the motors or generators. So if you want the rotor to rotate, then you need in the stator to create the rotating magnetomotive forces. And with three-phase systems, it naturally achieves that, which means that the three-phase induction machines or motors are self-starting compared to a single-phase motors. Of course, this is not our topic of discussion, but these are the advantages that I can mention about the machines. And it naturally produces the rotating magnetic field if you were to supply a three-phase voltage. Now, where this three-phase supply comes from? Of course, you will be thinking that it comes from a generator, right? But this is the type of generator, the three-phase AC synchronous generator that I've taken the photograph from madeinchina.com, and it's $450 per piece. But of course, if anyone asks you where this three-phase supply comes from, it comes from a generator. But this is a very basic question. But the most important, $1 million question is how three-phase voltage is generated. Well, that's the point of interest where we are at the moment, and I will try to explain as clearly as possible. Now, if you want to generate a voltage, let's say three-phase voltages, you need three separate windings or coils onto the stator. And you need a standard rotor made of copper or whatever the materials, with a squirrel cage, worm type rotor. And that rotor is connected to a wind turbine or hydroelectric system or generator or diesel power generator or whatever. If that rotor rotates inside the stator, it will cut the magnetic flux in the stator coils, and it will generate three separate voltages. So it's simple. When the rotor rotates and it cuts the magnetic flux in the stator, it will induce the voltage in those conductors. Just like a transformer, mutual induction is going on. But in this case, one part is rotating, another part is static. So it works onto the principle of mutual induction. Now, the question might be that why we call it three-phase? Why not simply calling it three voltages? Well, the reason is because here the mechanical engineers play a significant part, because the stator windings, let's suppose we have three separate coils, U, V, and W, suppose. Now these three coils needed to be connected to the stator, just like this. Now these three coils need to be connected to a particular angle difference. So you do know that the one complete circle has a 360 degree. So if you want to use a three-phase system, or if you want to generate three separate voltages from the stator, then your windings UVW must be displaced 120 degree with respect to each other. It works like this. If you want to generate a single phase, 360 degree divided by 1. If you want to generate two-phase, 360 degree divided by 2. If you want to generate three-phase, 360 degree divided by 3. And this gives you 120 degree displacement, mechanical displacement between the coils onto the stator. So what happens when your coils are 120 degree displaced onto the stator with respect to each other? When there will be mutual induction going on, there will be three voltages generated onto those conductors with the same magnitude, but the angles would be 120 degree with respect to each other. Right? So the angles, electrical angles, are proportional to the mechanical angles. And in this way, we get three separate sinusoidal waveforms. The one waveform starts at 0 degree. Let's suppose is coil U, the red one. The second one, V coil, starts at minus 120 degree. And the third coil starts at the angle of plus 120 degree. Now we use this phasor rotation, 0, minus 120 degree, plus 120 degree. But they are all the same thing. You can say positive angle, but because for the purpose of calculations, we try to simplify it. So we say that in the three-phase systems, you would have three separate voltages with the same magnitude, but at different angles. So for example, I have one room that has a single phase supply that we know. We always take it as a reference, 0 degree. But what if the room has a three-phase supply and you have three separate loads? Each load would receive the same 230 volts but at different angles, which will not make huge difference if your devices or machines are single phase. But it does make a huge difference if the devices require three-phase supply. So the question was how three-phase is generated. Well, it generates from the generator, and the generator has three sets of windings onto the stator. When the rotor rotates with the help of hydropower or diesel or oil or whatever the input, wind for example, then it will allow the mutual induction process, and there will be an induced EMF on to those stator conductors. And those induced EMF would be having the same magnitude but different angles. That would be 0, minus 120 degree, plus 120 degree. If you want to achieve 4-phase system or 6-phase system or 10-phase system, we call it polyphase systems. Yes, it is absolutely possible to generate 4-phase, 6-phase voltages. But we need to know why do we need to do that. Because the 3-phase actually allows us to transmit or transform the power from one point to another point cost effectively. If you were to have the 4-phase system, you need one more conductor to transfer that phase of the power, and this will incur the cost to the consumers and to the supply companies. So the 3-phase system is one of the cost-effective way to transmit the power, to distribute the power,